Today we are diving into something called cosmic chronometry. Now I know that sounds complicated, but stick with me. It's a field where our most precise clocks are actually probing the deepest mysteries of the universe. And in the process, they're forcing us to question the very nature of reality itself.
So, just think about this for a second. What if the instruments we build to measure things like distant stars and colliding black holes could actually do way more than that? What if they could open up a window into questions we've always thought were purely philosophical? Questions about reality and even consciousness? Well, that is the incredible possibility we're exploring today.
You see, we're dealing with two worlds that seem completely disconnected. On one side, you've got hard, measurable physics, gravitational waves, photon timing, super complex relativistic corrections, all stuff you can calculate. And on the other side, deeply abstract concepts, consciousness, the idea of time transcendence, and even mystical experiences like the Isra Mi that seem to totally defy space and time. It sounds impossible, but believe it or not, we're going to connect them.
Okay, so before we can build that bridge between those two worlds, we have to understand the tools. So let's start with the incredible technology that lets us time the universe with a precision that is, well, it's almost impossible to even wrap your head around.
You know, the cosmos is just full of these fleeting, incredibly violent events that happen in the blink of a cosmic eye. We're talking gamma ray bursts, the ripples from colliding black holes. To even notice these things are happening, let alone understand them, we need more than just powerful telescopes. We need unbelievably precise clocks. And the toolkit we've built is just astounding. We've got space-based gravitational wave detectors like LISA and Taiji, which are literally designed to listen for the faintest whispers of space-time itself. We have high-energy observatories like Veritas and Fermi that can time the arrival of a single photon from clear across the cosmos. And then there are these massive galaxy surveys, mapping out the grand structure of the universe over billions of years.
And here's why this is such a game changer. We don't have to rely on just one type of signal anymore. We're in the era of multi-messenger astrophysics. This basically means we can combine different cosmic signals, like seeing the flash of a neutron star collision and at the exact same time feeling the gravitational waves it sends rippling through space. It's like experiencing a cosmic thunderstorm of both sight and sound. You just get a far richer, more precise picture of what's going on.
So how is this incredible precision even possible? Well, one of the most brilliant techniques is called time delay interferometry. And honestly, the best way to think about it is like noise-canceling headphones, but for space-time. See, our own instruments create all these little jitters and vibrations, noise. TDI uses incredibly clever timing to digitally subtract all of that interference, which lets us hear the truly faint whispers of gravitational waves coming from these distant cosmic cataclysms. It's genius.
All right, so we've got the tools, and they are capable of some mind-boggling precision. Now let's turn to the theories they might actually help us test. We're about to pivot from concrete technology to the speculative frontier, where physics starts to touch on questions that used to be only for philosophers and mystics. Across pretty much all cultures and throughout history, you find these accounts of mystical experiences that seem to just break the normal rules of reality. You have narratives like the Isra Mi, which describe a total compression or even a transcendence of time and space. For centuries, these were purely matters of faith, but now some physicists are starting to ask a wild question. Do these ancient stories actually hint at a deeper, stranger reality that our theories are only just now beginning to grasp?
And that leads to an even more radical idea. I mean, the standard view is that consciousness is something that happens in the universe. It's just a byproduct of complex brains like ours. But some theories are now proposing the complete opposite, that consciousness isn't just a passenger along for the ride, but is somehow woven into the very fabric of reality itself.
Okay, one way to get your head around this is through something called the holographic principle. Now, this is a mind-bending concept, so stick with me, but here's the gist. First, imagine our 3D dimensional universe isn't solid reality, but is actually a projection, kind of like a hologram. Second, all the information that makes up everything in our 3D world could actually be encoded on a distant, flat, two-dimensional surface. And third, and this is the big one, if this is true, it might just be the key to finally uniting our two greatest theories of physics, general relativity and quantum mechanics.
Holograms, consciousness, mysticism. Yeah, I know, this all sounds incredibly abstract, right? But here's where it gets really exciting. We're now going to connect these huge ideas back to our technology and show how we might finally be able to test the untestable.
And this really is the big question. It seems like an impossible leap. I mean, How on earth can a machine that's designed to measure space-time wiggles from black holes tell us anything about the fundamental nature of reality or consciousness? Well, the answer is hidden in the incredible precision of the data.
Okay, let's really connect the dots here. Look at the gravitational wave detectors. They measure space-time with insane precision. If those measurements reveal tiny, unexpected jitters, like a flicker in the hologram, it might mean space-time isn't smooth but is actually emerging from a deeper level. Or take the high-energy telescopes timing photons from across the universe. If photons with different energies arrive at slightly different times, it could mean the speed of light isn't truly constant after all. And even the big galaxy surveys, by measuring distortions in space, can test a radical idea. Is time itself absolute, or is it actually dependent on the person observing it?
So, what happens if these tests start to show positive results? I mean, if we actually find something, the implications are nothing short of revolutionary. We would be looking at a completely new map of reality. For centuries, science has worked by breaking things down into their smallest possible parts. That's reductionism. But this new path suggests we might have been missing the bigger picture. A more holistic view might be needed, one where the entire system, including the observer, meaning us, is essential to truly understanding how the cosmos works.
The potential breakthroughs here are just staggering. I mean, we're talking about resolving the true nature of time itself, finally unifying quantum mechanics and gravity, the holy grail of modern physics, truly understanding the role of the observer in creating reality, and, in this stunning convergence, maybe even placing experiences we've always called mystical into testable scientific models. It's just incredible.
It all leads us right here. The next generation of these cosmic chronometers won't just be measuring stars and galaxies. They're going to be probing the very fabric of reality, forcing all of us to confront a really profound question. Are we simply observers looking out at the universe, or is the universe, in a way, observing itself through us? That is a thought that could change everything.